Hello students, this is Teacher Wang. I welcome you to Quarter 1, Module 15 with the topic on continental drift and seafloor spreading. This is week number 15, day number 3. At the end of the learning episode, you are expected to number 1. Differentiate continental drift theory and seafloor spreading theory. Number 2. Explain the causes of plate movement. And number 3. Realize the importance of seafloor spreading process relative to the continental drift theory. Before we start, let's answer a few questions. Read carefully and understand each sentences, then choose the best answer. Number 1. Who among the following coined the term seafloor spreading in 1961? A. Alfred Wagner, B. Clarence Dutton, C. Harry Reid, D. Robert Dietz. The answer is letter D. Question number 2. Which of the following supports the theory of seafloor spreading? A. Crustal age, B. Magnetic reversal, C. Correlation of rock layers, D. Continuous mountain chains. The correct answer is letter B. Question number 3. Most geologists rejected Wegener's idea of continental drift. What is the reason? A. They were afraid of the new idea. B. He used too many pieces of evidence to support the idea. C. He wanted to know what Earth looked like millions of years ago. D. He couldn't identify what would cause continents to move around. What is your answer? The answer is letter D. Question number 4. What two words are best used to describe how the seafloor spreads? A. Magma and convection, B. Magma and convention, C. Earthquakes and volcanoes, D. Earthquakes and convection. Think of your answer. The answer is letter A. Magma and convection. Number 5. How long ago did Pangaea split apart? A. 1 million years ago, B. 20 million years ago, C. 200 million years ago, D. 1 million years ago. What is your answer? The correct answer is letter C. Congratulations! In your previous lesson, you have learned about Earth's mechanism. Can you still remember about plate tectonic features? Let's have some practice exercises to refresh you. Are you familiar with this picture? Let's try to identify its phenomenon. Fill in the box with the missing word. Write your answer in your workbook. I'll give you 5 minutes to answer. Let's check your work. I hope that you get all the correct answer. It's nice to know that you still remember the past lesson. Let's discuss. Do you really wonder if someone told you about amazing things? Did you heard that plates are moving? Tectonic plates is a giant pieces of the Earth's crust that fit together and move around on the Earth's surface. How would you describe the picture? Land masses joined together. It is also known as Pangaea, meaning all Earth, or it also known as supercontinent. This claim was made in the 90s by Alfred Wegener, a German polar researcher, meteorologist, and geophysicist. Let's watch the short video to discuss about Pangaea.
In the early 20th century, the German scientist Alfred Wegener noticed that the eastern coast of South America and the western coast of Africa fit together nicely, almost like two pieces of a puzzle fitting together. Then Madagascar fit nicely around the side of Africa, while parts of India seemed to have a place as well. Despite heavy criticism, Wegener went on to publish the book The Origin of the Continents and Oceans in 1915, pushing the concept of what he called Urkontinent, meaning supercontinent in German, except in a 1920 edition of the book where, for a single time, he called the land the Pangaea of the Carboniferous, coining the term from the Greek pan, meaning the entire or all, and Gaia, meaning earth. Of course, it was the Latinization of this word that became the more common phrase now, Pangaea. And today, Pangaea and the larger theory of plate tectonics are more or less common knowledge. Beyond that, though, I don't know if I've ever actually seen a good prediction on what the continent actually looked like. Most maps you'll find are either too simplistic for my taste or just an artistic representation of Pangaea, which can trade accuracy for aesthetic. So what I'd like to do today is make a rough estimate of what some of the geography of Pangaea was like, and hopefully by the end we'll have a cool map or something. Obviously, this will just be an approximation based on what we know so far about the supercontinent. So with that in mind, let's get started. First, Pangaea itself existed for around 160 million years, forming around 335 million years ago, and breaking apart roughly 175 million years ago. Over this time, Earth's geological engine was still turning underneath, meaning that on a geologic timescale, Pangaea would have been constantly changing, and so one general map of Pangaea can't really be made. Instead, we're going to need to pick a specific time in Pangaea's past to look at. This one's going to be a bit arbitrary, but we're going to aim for between 190 million years to 230 million years ago. This was around the time of the Triassic-Jurassic extinction event, during which 20 to 30% of all marine species went extinct. For this time, the most accurate map for Pangaea I could find was this one. But using this, we can now begin to look at specific features, and to start, I'd like to look at some of the mountain ranges that would and would not have existed during this time. For starters, nearly every major mountain range on Earth today had not formed yet. The Himalayas, for example, only began to form 50 million years ago when India collided with Asia. And overall, it was the tearing apart of Pangaea that actually gave us many of our mountains. And the reason these all happen to be our tallest is because they haven't had enough time to erode. So to find out what would have been around during this time, we need to look at some of the oldest mountains remaining on the Earth, such as the Appalachian Mountains of the United States, the Little Atlas Mountains of Morocco, and the Scottish Highlands of Great Britain, all of which are nearly 500 million years old. Now, it just so happens that these three mountain ranges would have formed a single continuous mountain range across the supercontinent called the Central Pangaean Range.
Continental drift is the theory that the Earth's continents have moved over geologic time relative to each other, thus appearing to have drifted across the ocean bed. The following evidence were used by Wegener and other supporters of the continental drift theory. 1. Paleontological evidence. There is similarity of certain fossils found on the continents of both sides of Atlantic. 2. Glaciation. A glacial period is an interval of time within the ice age that is marked by colder temperature and glaciers advances. The glacial deposits and pattern of glaciation on 5 continents in the hemisphere were recognized. In South America, India, and Australia, the ice appeared to move inland from the oceans, a phenomenon quite not happened unless there was a landmass where the ocean basin now exists. Number 3. Structure and rock type. Geographers found that coastlines of several present-day continents would perfectly fit together, particularly Africa and South America. Last, paleoclimate evidence. Wegener reconstructed old climate zones to prove that appears shifting of climate belts over time. He used the distribution of specific rock types. He determined the distribution of climates in ancient times. Seafloor spreading is a process that occurs at mid-ocean ridges, where new oceanic crust is formed through volcanic activity, and then gradually moves away from the ridge. It occurs at divergent plate boundaries. As tectonic plates slowly move away from each other, heat from the mantle's convection currents makes the crust more plastic and less dense. The less dense material rises, often forming a mountain or elevated area of the seafloor. Evidence to support seafloor spreading theory are the following. 1. Earthquakes and volcanic activity. 2. Mid-ocean ridge and hydrothermal vents. 3. Magnetic rock alignment. And 4. Rock dating techniques. Time to answer your activity. Do it in your activity notebook. Please do activity number 1, entitled Continental Drift and Seafloor Spreading. Using a beam diagram, compare the continental drift theory from seafloor spreading theory. Activity number 2, plate movement. Complete the concept map about plate movement. Activity number 3, let's move. Study and analyze the pictures showing the process of continental drift and seafloor spreading. Good luck! Summarize what you have learned. Answer the following. Fill in the box to complete the concept map. I'll give you 5 minutes in thinking your answer. Let's check your work. Hope everybody got the correct answer. There were several evidence presented to support the continental drift theory and seafloor spreading theory. Let's find out their importance. To know more about this, do activity number 3 entitled Let's Move. Have fun! Let's now proceed in your post-test. Number 1. Which of the following can you infer from the continuous movement of the lithospheric plates over the asthenosphere? A. All the continents will cease to exist. B. All the volcanoes in the Philippines will become inactive. C. The continents will not be located in the same place as they are now. D. The islands of the Philippines will become scattered all over the world. What is your answer? The answer is letter C. The rocks on the ocean floor show evidence that the magnetism alternates north and south as you move along the seafloor. This evidence of seafloor spreading is reflected in the rocks on the ocean floor. The name for this evidence is called A. Plate motion, B. Magnetic reversals, C. Crustal subtraction, D. Magnetic solidification. What is your answer? The correct answer is letter B. Magnetic reversal. Number 3. Youngest oceanic crust is found at the mid-ocean ridge. Age gets progressively older as you get farther from the mid-ocean ridge. Why is the Earth not expanding in size? A. The older ocean crust is weathered and eroded away. B. The older crust is being recycled at subduction zone. C. The deposition of the older crust decreases the mass of the Earth. D. The mid-ocean ridge is becoming so large that it is consuming the older the crust. What is your answer? The correct answer is letter B. Number 4. Below is a picture of seafloor spreading. How are the ocean crust moving? A. Converging. B. Diverging. C. No movement. Or letter D. Sliding. What is the correct answer? Letter B. Diverging. Number 5. If all the inner layers of the Earth are firm solid, what could have happened to Pangaea? A. The thickness of the lithosphere. B. The age of oceanic lithosphere. C. The dip to the seafloor. D. All of the above. What is your answer? The correct answer is letter D. Congratulations! Nice work! Keep safe. God bless us all.